CLO1.5, describing data using measures of variation, such as range, variance, and standard deviation. Okay, so before we get too into it, we are going to look at an example, and hopefully through this example you'll see why we need these other measurements. So this example below has the wait times for two different banks, people who walk in the bank and how long they had to wait. And as you look at the two different banks, the data is different. You can see that it's different, and you might ask yourself the question, which bank would I prefer to go to? So it depends. There's no right answer to this, but some people might look at the first bank and see, well, the wait times are pretty consistent. That's a word we will use a lot in this lesson. The wait times are consistent, meaning they're pretty predictable, they're close together. If I chose Baja Bank, that means that I can pretty reliably predict that the wait would be somewhere between 6 and 7 minutes. But if you chose Mumsar Bank, these are a little more varied. This is another vocab word we would use. Varied meaning there's a big difference. There's a big spread between the wait times. It could be that I use this bank and wait 4 minutes or 10 minutes. It's hard to know. Now up to this point, in terms of math measurements, all we have learned how to do is find the measures of center, the mean, the median, and the mode. So I'll show you those calculations for each of these two banks. So you can see for each of these two banks, the mean is the same. And the median is the same. You can trust me, I didn't want to go ahead and do those calculations, but if you did, they are the same mean, the same median, and even the same mode. But as we discussed, they are different. There's different preferences and different things that you can see and as we consider either one of those two banks. So we need another set of measurements that would help us describe those differences. So instead of measuring the measures of center, we are going to have other measures which are called measures of dispersion. And the word dispersion just means how spread out is the data. So the three measures of dispersion we will learn about in this lesson are the range, the standard deviation, and the variance. Let's start with the range. The range is the easiest, it's the most simple thing to measure. You just take the maximum value of the data set and subtract the minimum value of the data set. So let's go back to our example about the bank wait times, and we can find the range for each bank. We can say for Baja, remember, and I'll just write this quickly, I'll just say it's the biggest data point minus the smallest data point is going to be the range. And so for Baja Bank, we've got the biggest minus the smallest, 7.7 minus 6.5. It looks like the range is 1.2 for Baja Bank. Let's do the same for Mumsar Bank. So for Mumsar Bank, we take the biggest data point minus the smallest data point. And again, thankfully, these are listed in order already from smallest to biggest. And we will get, in this case for Mumsar Bank, a range of 5.8. Now, when the data is more spread out, this is what we call more varied or more dispersed. That's the vocab we use. When the data is less spread out, we call it more consistent. That means the data points are closer together. So we will use these vocab words a lot to describe how spread out the data is. If it's not spread out very much, it's more consistent. If it is spread out, we call it more variable or more varied, or they might say more dispersed. I want to do one more example to point out that sometimes the range is not a very good measure of dispersion. And I'll take you back to an example we did in a previous video, and it was 10 students responding to how many speeding tickets they have gotten in the last year. And what you'll notice here is one of the students gave an answer that was much different than the rest. When you have an answer that's much different, much higher or much lower than the rest of the data points, it's called an extreme value. So if you look here and you find the range of this data, you will see the range is the biggest minus the smallest, 92 minus 0. That it seems as though this is not consistent. The issue, though, is that if you look at the other 9 pieces of data, it's very consistent. So saying that this data is not consistent is not really giving you the full picture. In fact, most of the data was very consistent, and we just had one extreme value, one outlier. So the summary to note is that the range is not very useful when there is an extreme value. Okay, so in summary, the range, which is the biggest data point minus the smallest data point, has some advantages. It's simple, it's quick to calculate. However, we do not use it that often because it only depends on the smallest and the biggest data point. It tells us nothing about the rest of the data points, and therefore it's not very accurate if there is extreme data. So the next slides we're going to go through are the other measures of center, one of which we use a lot. Okay, we will talk about the standard deviation now, and the standard deviation is much more useful than the range because it uses all of the data points. It's actually a pretty ugly formula. I'll pull it up here. But here's what this formula means. It basically, this symbol right here is mu, and the first thing you're going to do is mu stands for mean. You're going to find the mean. It means find the average for the data set. Then the second thing you do is you take every individual data point and you see the distance that that data point was away from the mean. Now this part, the squaring and the square rooting, squaring something and square rooting something are opposite functions, but what it does is it gives you only positive answers. So that basically has the effect of saying it doesn't matter if the point was less than the mean or more than the mean, we're just going to take the positive distance. And then this symbol, as you remember, means add them all up, and if we divide by n, that's basically taking the average. So if I had to give a simple definition of what the standard deviation is, I would say it's the standard deviation is the average distance each data point is away from the mean. Now in this class, you're lucky. We're not going to make you do these manual calculations, so we're not going to need that formula. We're just going to use our calculator to find the standard deviation. So here are the calculator steps to find the standard deviation. Similar to what we learned in measures of center in the last lesson, you always have to start out by entering your data. To enter the data, the first buttons you will press are mode 3, 1. If you have the white calculator, it will be menu 6, 1. Then you should see a table come up which has an X column and a frequency column. You should enter your data and press AC to save it. Then you will press Shift 1, 4. If you have the white calculator, you'll press Option 2. But if you press Shift 1, 4 and you have this calculator, you should see a menu of options. So before we move on, let me describe what each of these options mean. N is just the number of items in the data set. X with the bar on top, we did in the last lesson. This is just the mean that we calculated. Now the menu options number 3 and 4, these are the ones we care about. Number 3 is the population standard deviation. And if you press number 4 in the menu, that will give you the sample standard deviation. And remember back from CLO1.1, the difference between a population and a sample. The population is every member of a group, every employee, or every student, whereas a sample is just taking some of the members of the group. In reality, the calculator numbers that you get, whether you press population or sample, they will be very close, and you'll know which one to use based on the question. The question itself will tell you. So in summary, if they ask for the standard deviation, you'll start the same way. You'll press mode 3.1 or menu 6.1. You will enter all the data, then press AC. Then if they ask for the sample standard deviation, you will press Shift 144 and it will give you S equals. Or if they ask for the population standard deviation, you will press Shift 143 and it will give you the population standard deviation. If you have the white calculator, you press option 2 and it will just give you a list of all the information that you need, including the sample standard deviation and the population standard deviation. So let's do an example to practice it out. So here we have the data collected, which was the number of absences, and the frequency is measuring the number of students who had each different category of absences. So either way, we start the same. We're going to press mode 3.1 on our calculator or menu 6.1, and then we are going to enter the data and press AC. So let's stop this recording and do that. Okay, I entered my data. Now if we want to find the sample standard deviation, I'm going to press the button Shift 144. So I will see this letter and get the sample standard deviation is 1.137. So in simple terms, that means on average, each data point is about 1.137 away from the mean. Let's do another example. Now we'll find the population standard deviation, and this one gets a little more complicated. Why? Because we're dealing with grouped data. So as you'll remember from the last lesson, you can't enter the data into the calculator when it is in the grouped format. So what you must do first is find the midpoints. So how do you do that? You add the endpoints and you divide by 2. So if we were to add 100 and 150 and then divide by 2, we would get a midpoint of 125. I'll do this quite quickly. The midpoint here would be 175, 225, 275, 325, 375, and lastly 425. So when we enter our data into the calculator, we are going to use these 2 columns. We would use this column for our data and the second column for our frequency. So first step is we press mode 3.1 or menu 6.1 if you have the white calculator. Then we enter the data into the X and Y columns and we press AC. So stop the video right here and let's all do that. Okay, now that we've entered all the data in, if we want to find the population standard deviation, we are going to press Shift 1.4 and then we'll see our menu and we'll take that Greek letter, which is a sigma, and find the population standard deviation. So pressing Shift 143 equals, we get 82.99. Okay, here's another example of how they might ask a question about standard deviation. They'll give you data for 2 different teams. I'm not sure what sport or what kind of scores, but they've collected the data and they're asking us which is more consistent. So just as a reminder, the word consistent means the data is closer together. And it asks us to figure out which data set is closer together by using the measure of dispersion, the sample standard deviation. So really the more consistent one is going to be the one with the smaller standard deviation. And why is that? Remember, standard deviation is measuring the distances. It's the average distance that each data point is away from the mean. So if the distances are smaller, the standard deviation is smaller. That means the data points are closer together and they are more consistent. So first thing we need to do for each team is calculate the sample standard deviation. So for each team separately, we're going to take our calculator, press mode 3.1 or menu 6.1, and then enter the data and press AC. So why don't you stop the video right now and just do that for team A. Press mode 3-1, enter the data, and press AC. And as you do that, you might notice that there's two columns, the X and the frequency, and you're putting all the data in the X, and as you're doing that, the frequency fills up with ones. Since this isn't a table, we can just leave the frequency with those number ones. Now, when we want the sample standard deviation, we will, as our third step, press Shift 1, 4, and remember the sample is the letter S, so Shift 1, 4, 4, and you'll find the sample standard deviation for team A. And for team A, we will get 13.92. Let's do the same thing for team B, so we're going to press mode 3-1. We're going to enter the data for team B, so pause the video here and do that. So again, you are going to look at these data points, mode 3-1, enter the data. When you're entering it, you're going to, since this is just raw data, 19 equals 35 equals 0 equals 4 equals, the frequency is just 111 going down, and you can just leave it. That's fine. Then you're going to press AC, Shift 144, and we will get a sample standard deviation of 13.098. So that rounds to be about 13.10. So the question is, which team is more consistent? That means which team has data points that are closer to the middle, less spread out, so that would be a smaller standard deviation. In this case, it looks like team B is more consistent. And just as a reminder, the one with the larger standard deviation would be called more dispersed or more varied. Okay, we have one more measure of dispersion that we need to talk about. It's called the variance, and the variance is very closely related to the standard deviation. So in order to find it, we will usually have to find the standard deviation first, and then we square it. So in order to find the variance, you take the standard deviation that you already found and you square it. There are times and some problems that you will be given the variance, and then you have to work your way backwards to find the standard deviation, in which case you take the square root. Let's do a few examples. So for example, if the variance is 25, the standard deviation would be the square root of 25, which is 5. If the standard deviation is 6, then the variance would be 6 squared, and so you would get 36. So one thing you want to remember is that the standard deviation is always the smaller number compared to the variance. Okay, let's do a few more examples of questions related to measures of dispersion CLO1.5. So in this example, we're given some grouped data which tells us about the ages of different U.S. presidents when they became president. So first thing we need to do is enter the data in, well actually before that, Part A. Part A is quite simple. Part A is asking us for the range. And if you remember, the range is just the maximum data point minus the minimum data point, or the biggest data point minus the smallest. Remember, on the left-hand column, that's the data. The right-hand column is the frequency. So the absolute biggest data point is 69 in this case, and the absolute smallest is 42. And so we can say the range in this case is 27. Now, unfortunately, we don't use range very often because the weakness of the range is it does not take into account all of the other data points. So what we will do is find the standard deviation. That's what Part B is asking us for. And as you remember, the way the standard deviation takes into account all of the data points is it takes each data point and it measures how far away they are away from the mean, and then it averages those distances. So we will use our calculator to find this. First step in our calculator, we'll press mode 3-1, if you have the other calculator, you'll press menu 6-1. You'll go ahead and enter all your data into the X and the frequency columns, and then you will press AC. So let's stop the recording and make sure we all do that. But before we're able to do that, we need to remember, since this is group data, we need to calculate all the midpoints. You're not able to enter all those endpoints of the group, so you need to calculate the midpoints. So for the first column, for example, you would do 42 plus 45 and divide by 2. So in this case, we get 43.5. For the next column, you would do similarly. You would add 46 plus 49, divide by 2, you will get 47.5. And to save time, I just calculated all those midpoints and entered them in. So when we press mode 3-1 in our calculator, these are the two columns we will be using to enter our data. So now let's stop the recording and catch up and enter that data into the calculator. Okay, now that the data is entered, you can press Shift 1, 4, and it says population standard deviation, so we'll press the number 3 because we want this symbol, the population standard deviation. In this case is 5.76. Okay, and lastly, it asks for the population variance, and as you hopefully remember, the variance is another measure of dispersion that is just equal to the standard deviation squared. So in this case, you would take the 5.76 and square it. Even better is if you have that number already sitting in your calculator, just press the answer button squared, and then it's even more accurate without having to lose anything for rounding error. So we will get that the population variance in this case is 33.2. Okay, here is another example, and as you first look at it, you might think we don't have enough information, but we do. So let's look at what it says. It says all 20 students in a class had a score of 6 on a quiz. That means every single student had the same exact score. So the mean, you would add up all the scores and divide by the total number. So in this case, we would do 6 plus 6 plus 6. There's 20 of them. And then we would divide by the total number. In the end, that's going to be 6 times 20 divided by 20. So you will get that the mean is 120 divided by 20, which would be 6. Totally makes sense. If everyone has the same score, then the mean will be that score. So then it asks, what's the standard deviation of the data? Remember, the standard deviation is measuring the distance that each score is away from the mean. But since each score is exactly sitting on the mean, then each score is not any distance away from the mean, and so the standard deviation in this case would be 0. It's a very unusual case when the standard deviation is 0, and it only happens when all the scores or all the items in a data set are exactly the same. Okay, for our last example, it's telling us a lot of information about 3 different sets of data, set A, set B, and set C. We don't know the actual data, we're not given that, but we're given facts about the data set. So the first thing I would do is just kind of make a table to organize everything that's being told. So I see them telling us about the variance, the standard deviation, and the mean. So I will make those categories mean, standard deviation, and variance, and that way we'll have a place to put all the information they tell us. So let's look at what they tell us in the question. The variance of all the numbers in set A is 2. The standard deviation of all the numbers in set B is 3. And then the variance for all the numbers in set C is 4. And then it also tells us the mean for all the sets, the average for all the sets is 5. Now they're asking which set is most dispersed and which set is most consistent. When they're talking about dispersed and consistent, they're asking how is the data spread out? Is the data close together or not close together? So when they ask about dispersion, we don't really care about the measure of center. That's not what they're asking about. So to compare who's the most dispersed or consistent, we need to compare same with same. So either compare all the standard deviations together, or you can compare all the variances together and see which one is smaller and bigger. So in order to do that, we'll need to figure out the missing information. So remember, the variance is always bigger than the standard deviation. In this case, the standard deviation would be the square root of 2, which is approximately 1.4. And when we're given in set B the standard deviation, the bigger value, you would take it and square it. And we're going to get the standard deviation here is 3 squared, which is 9. And then for set C, we were given the variance. So we will go backwards and find the smaller value is the square root of that number, which is 2. So now then they ask us what set is the most dispersed. That means the most spread out. So which measure of center is measure of dispersion is the biggest. In this case, the measure of dispersion and the variance are biggest here. So this set B is the most dispersed. And then conversely, when they're asking which set is the most consistent, that means the smallest standard deviation or the smallest variance. And so in that case, we would have set A, the most consistent, because that's telling us the distances between the data points is the smallest. The data is closest together in set A. So those are the examples, and I hope now you have a good understanding of the different measures of dispersion and how we use them to answer questions.